Okay, now we just want to give a lot of examples. The best way of teaching any subject is through many, many examples. So we would like to give now many examples of finding that the idea is we're giving you the sun and the moon, and then you get from that information you get to figure out the in other words we're giving you the Oirich Sheni and the Roichev Sheni, and from there you're passing all the steps. You're getting the Magal HaYerech, the Oirich Shlishi, Oirich Revi, and then you get Manas Goyva Medina, and the final is called Keshes Riyah. It's very good. You do yourself many, many examples until you get so used to it that you have what's going on here. So I'll give you some examples that I did myself, and I would like to give examples, maybe 20 examples. I guess you learn also how to use a calculator, because sometimes you have to tweak some stuff when you get to the calculator. So it's basically the first example that I'm going to give. I'm going to show the formulas, and then you have to look always at the first example to see what formula I use. There's altogether this whole call it formulas that we got here. We have, I could say, 4 basic formulas, and then they can be divided in each one. There's some that have a few formulas inside. So let's start with this. This formula goes find Oirich Shlishi. This is a simple formula. Take the arc tangent, that's the inverse tangent. You gotta use a scientific calculator. You'll know how to how to play around till you figure out how to use that. You have to get in the sine x. X is the Oirich Sheni. In this case, it's 23. So this is what you do. You take the inverse tangent of sine 23 minus tangent 5 over tangent 23.5. Tangent 5 is because we're dealing here with a latitude of 5. Divided by cosine x. That's cosine of 23. And you gotta type in the brackets properly. If not, you get a wrong answer. So all these things you have to learn how to, the order of operations and so on. Okay, so you do this to 23, you should get 20.96. So this is the Oirich Shlishi. The Oirich Shlishi is 20.964. And it sounds good because we know that in the beginning, in next to Tle, it's a big difference. The Magal HaYerech, the Rambam calls it, is large, and it's a negative one. It means you subtract. So it makes sense. Now, find Oirich Revi point. Oirich Revi. First for sun point. So Oirich Revi is quite a cumbersome calculation. There's no shortcuts for this. I tried different formulas. This is the one that the textbooks give you. So what we need to do, we need to convert 2 points, the sun point and the Oirich Shlishi point. We'll call it the fake moon because we try to imagine the moon is there at that point at the 20.964. Okay, so first we do it for everything we do for the sun and for the fake moon. So we have to find a few values to get this. It's a 4-step process. First, we make a certain value a, that's arc sine of sine 10. That's where the sun is, times sine 23.5 divided by sine 58. That you get a value of 4.6. Then we get a value of w. That's the arc inverse tangent again of tangent 10 cosine 23.5. This is another value. Then we get the value of, it's a value of c minus w. That's the value. It's the inverse cosine of cosine a cosine w divided by cosine 10. 2.4. This whole process I took from a spherical trigonometry textbook that he explains this why you need to do all these steps. But this is what you need to do. Finally, C minus W. In order to get C, you have to add to the value of C minus W. You got to add W because you have to find C, not C minus W. So you add to 2.4857, you add 9.18, and finally you get 11.67. This is the first value C, and it means, to be very practical, that when the ecliptic in Israel, the point of 10 of the ecliptic sets, then also the point of 11.67 of celestial equator sets simultaneously. This is what it means practically. You're finding out what point of celestial equator sets when 10 of the ecliptic sets. Now you redo this whole thing. You got to redo it for the Orch Shlishi point. That's 20.9. But since it's so many steps, so it's always good not to use too much numbers. You get confused. So just use 20.964. And again, you find all these values again. A, W, C minus W, C. You'll see that the value of C turns into 24.527. So we got it two C values. And that means, as I said before, celestial equator point that sets. When that point sets. When the second value, it means when the point 20.964 sets, then the celestial equator 24.527 sets. Okay. Now you subtract these two values and you get 12.856. This is called Oirech Revi. It's the time it takes from point A to point B to set. You can measure it. You take this number 12.856. You multiply it by 4. You know exactly how many minutes it is. I'll do it now. 12.856 times 4 is 51 minutes. 51.42. That's how much minutes it takes for the portion of ecliptic 10 degrees till 20.964%. Okay, now we have Orch Revi. I think this part, in my opinion, is the most, where you can get the most mistakes or more confusing. So practice on this part. Now we'll go to the third part of the equations, and that is the Manos Goiva Medina. So we take now the declinations of the points of the ecliptic. So first you take of the Orch Shlishi point. That's declination of Orch Shlishi point is. So in order to figure out the declination of any point of the ecliptic, you need to take this formula here: arc sine 23 times sine of the point that you're dealing with. So we're dealing here with the Orch Shlishi point. That's 20.964. So you know that declination is 8.2021. That's the declination of that point of the ecliptic. However, the real declination of the real moon, as I said the whole time, this is a fake moon. We have to now do something that's called Manas Goiva Medina. That is, to do it the mathematical way, we have to do like this. We take the A cosine, inverse cosine, of cosine maglia reich times cosine 5. That's a certain triangle that we need to add here to get or subtract. But now we're not adding because we have a positive latitude. So it's cosine 5, it's positive. So here you see you get Maglia Reich would be 23 minus 20, because 23 is the Orch Sheni, and 20 this is called Maglia Reich. Cosine Maglia Reich times cosine 5. This is the extra declination. So we got here this 5 degrees extra declination for the real moon. So again, there's one declination that's 8.2. This is where the fake moon is. That's the declination of the fake moon. Declination of the real moon is 8.2021 plus 5. This is the extra, the Rambam calls Manas Goiva Medina, this extra declination that we need to add. So we need to find what's the difference in setting times for a same right ascension star. However, one star has a declination of 8.2021. The other one has 13.5 0.59. Yeah, this plus that. So we take this formula. Setting time different for two styles of same relationship but different nation. So this is the last formula. Maybe I should call this the fourth formula. A cosine negative tangent 32 tangent declination high minus A cosine minus tangent declination low. So he put in, this is the setting time from it reaches the prime meridian till the setting time for the high declination. This is for the lower declination. The answer is 3.5. This is the amount in degrees, and you can multiply that by minutes. That will be the how much minutes it takes the longer to set for the high declination. It's about 12, maybe 14 minutes. The final catch is 3. Yeah, it's Orach V plus 3.52. That is 16. So now you convert this to minutes. It's 65 minutes from sunset to sunset. So this is the whole, the whole parsha here, the whole Megillah. I would say it's 5, 6. I don't know how many. I didn't count how many steps. Maybe it's 10 steps. Whatever it is, just make sure to do it neatly and slowly in the beginning because it takes time to get used to all these numbers. And then this is the last thing you find out is the final thing that we were interested is the time it takes in minutes from sunset to moonset. I redid this, the Rambam's method. It's to show how fast the Rambam's method goes and how very close it is. It could be very, very close, sometimes it's only a little bit close. So the Rambam says like this. First, the Rambam says take 2/3 of the rochav. So it's 5 times 2/3 because it's 5 degrees. 5 degrees rochav. So it's 10/3. Now we deduct this from Orach Sheni because, so why do we take 2/3? Because the Rambam says that by every mazel, he says, it depends where the moon is. So he says if it's in the Taleh, then you take 2/3 and you have to deduct it. So anyway, you deduct 2/3 of, you have to first take 10/3, now deduct 13. That's where the moon is. You deduct 2/3 of 5. That's you deduct 10/3. So 9.66 is the Orach Shlishi. The Rambam says for the Orach Revi, again you have to know where you're dealing, which part of the ecliptic you're dealing. The Rambam gives you all kinds of areas, and he says for this area of Taleh, you make time, Tosef Shetusa, you add a 6, so you make 7/6 times 9.66. It's 11.277. Now the final step of the Rambam is to always add 2/3 of the latitude of the Reichav, and here we're dealing with 5, so we add again to 11.27, you add 10/3, 14.6. The final cash is 3. So there's a discrepancy, as I wrote, 16.3, 14. It's some kind of discrepancy, not too much. This is the 1.7 degree discrepancy. So anyway, I hope you enjoyed this. This is a nice example that we can actually, really understand well what all the steps are, Rambam's method and the calculated